October 13th, 1942, 03:47 hours, Henderson Field, Guadalcanal. The wrench slips. Sergeant Joe Foss catches it before it hits the mud, his hands black with oil and blood from a gashed knuckle he doesn't remember cutting. Around him, the wreckage of war glows under makeshift floodlights, cargo parachutes stretched over bamboo poles, powered by a sputtering generator that coughs like a dying man. The air smells of high-octane fuel, burnt metal, and the jungle rot that creeps into everything on this island. 3 Grumman F4F Wildcats sit in pieces. One has no engine. Another has an engine with a cracked cylinder head. The third has bullet holes through the oil cooler and a prop bent like a question mark. Behind him, a Marine lieutenant checks his watch. "Sunrise in 2 hours, Sergeant. Tokyo Express will be right behind it." Foss doesn't look up. His hands move across the engine block, feeling for the hairline fracture he knows is there. Somewhere in the darkness, another mechanic is pulling pistons from a Wildcat that burned 3 days ago. Another is hand-filing a replacement valve from a piece of Japanese truck axle. By dawn, these planes will fly. They have to, because 12 Japanese Zeros are coming, and right now the entire Cactus Air Force has exactly 4 aircraft that can meet them. The wrench turns. Metal bites metal. The work continues. Understanding what brought these men to this moment requires stepping back 6 months to a war that was being lost in slow motion across the entire Pacific. In the spring of 1942, the Empire of Japan controlled an area larger than the continental United States. From the frozen rocks of the Aleutians to the jungles of New Guinea, from the beaches of Burma to the coral atolls of the Marshall Islands, the rising sun flag flew over conquered territory at a pace that stunned military planners in Washington. The Japanese combi, Ned Fleet ruled the ocean. Japanese pilots, veterans of China and Pearl Harbor, dominated the sky with a kill ratio that made American commanders physically sick when they read the reports. The Battle of Midway in June changed the strategic calculus, but not the daily reality. America had stopped Japan's advance, sunk 4 carriers, and bought time. But time for what? The United States was fighting a global war on multiple fronts with an industrial base still converting from peacetime production. Every aircraft, every engine, every spare part had to travel thousands of miles across submarine-infested waters just to reach the fight. The Japanese, meanwhile, operated from established bases with mature supply lines and repair facilities built over years of conquest. Guadalcanal represented America's first major offensive operation in the Pacific, and it was launched with dangerous optimism. On August 7, 1942, the 1st Marine Division stormed ashore and captured a partially completed Japanese airfield in the northern lowlands of the island. The logic was sound. Whoever controlled that airfield controlled the air. Whoever controlled the air controlled the sea approaches. Whoever controlled the sea approaches controlled the entire southern Solomon Islands chain, and with it the sea lanes to Australia. The Marines renamed it Henderson Field after a pilot killed at Midway, and within days the first American aircraft began landing on its single coral and dirt runway. But the Japanese had no intention of conceding the island. What followed was a grinding, desperate struggle that military historians would later call one of the most brutal campaigns in modern warfare. Japanese warships sailed down from Rabaul almost every night in what became known as the Tokyo Express, shelling Henderson Field with battleship guns, landing fresh troops, and withdrawing before dawn. Japanese bombers attacked almost daily. Japanese infantry launched fanatical night assaults against the Marine perimeter. For the men trying to keep aircraft flying from Henderson Field, the situation bordered on impossible. There was no prepared infrastructure, no maintenance hangars, no machine shops, no parts depot. Everything had to be improvised from whatever materials existed on the island or could be salvaged from wrecked aircraft. The mechanics worked in open-air revetments, exposed to tropical downpours that turned the airfield into a sea of mud, and to Japanese bombs that cratered the runway and sent shrapnel ripping through parked planes. Supply convoys arrived sporadically and always under strength. Cargo ships, terrified of Japanese air attack, would race in at dawn, unload frantically, and flee before noon. Many never made it at all, torpedoed by submarines or sunk by bombers. The supplies that did arrive were often the wrong items entirely. Crates of bayonets when what was needed was engine oil, pallets of rations when cylinders and pistons were the difference between survival and annihilation. Requisition forms meant nothing. Proper channels were a fiction. The paper reality of military logistics dissolved in the face of Guadalcanal's mud and chaos. Aircraft availability became the single most critical factor in the campaign. On paper, the Cactus Air Force, as it was informally known, was assigned dozens of fighters and bombers. In reality, on any given morning, the number of flyable aircraft could be counted on two hands. Planes that landed damaged in the morning needed to be flying again by afternoon. Pilots were flying 3, sometimes 4 sorties per day in aircraft that should have been grounded for major overhaul. The mechanics were performing 100-hour maintenance checks in 100-minute windows between raids. The Japanese understood numbers. Their intelligence officers tracked American aircraft through radio intercepts, coastwatcher reports, and pilot debriefs after combat. They knew how many planes had landed on Guadalcanal. They knew how many they had shot down or destroyed on the ground. The math from their perspective was simple and increasingly favorable. Attrition was grinding the Americans down to nothing. What the Japanese could not calculate was the variable that existed in the mud between the wrecked aircraft and the makeshift workshops. The American mechanics were not products of formal military aviation schools. Most had been civilians 9 months earlier. They were farm boys from Iowa who had rebuilt tractor engines in dirt floor barns. They were factory workers from Detroit who knew how to make a production line move. They were garage owners from small towns across the Midwest who had spent their lives making broken things work with whatever was on hand. The military had taught them the specifications, the manuals, the proper procedures. Guadalcanal taught them to forget all of it. The Pratt & Whitney R1830 radial engine that powered the F4F Wildcat was a magnificent piece of engineering. 14 cylinders arranged in 2 rows producing 1,200 horsepower, designed to tolerances measured in thousandths of an inch. The technical manual for proper overhaul procedures was 3 inches thick. It specified clean rooms, precision tools, factory-certified parts, and trained specialists. Henderson Field had none of these things. What it had were men willing to ignore what couldn't be done and focus on what had to be done. Sergeant Robert Gaylor, a mechanic from the VMF 224 Squadron, later described the process in terms that would have horrified Pratt & Whitney engineers. Engines were pulled from crashed aircraft while the metal was still warm. Cylinder heads cracked by bullet strikes were welded back together using rods scavenged from Japanese vehicles. Pistons that didn't match were hand-filed until they fit. Magnetos were cleaned with gasoline and dried with compressed air from hand pumps. Oil filters were improvised from parachute silk. Gaskets were cut from leather boots. When precision measuring tools were unavailable, mechanics used their hands, their ears, and their instincts developed over years of making things run. The Japanese flew Mitsubishi A6M-Zeros, aircraft designed and maintained according to rigid Japanese industrial doctrine. Every part was manufactured to exact specifications. Every maintenance procedure followed established protocol. Japanese mechanics were skilled, but they worked within a system that demanded conformity and precision. If a part was unavailable, the aircraft was grounded until proper supply channels delivered the correct replacement. This approach worked superbly when supply lines were intact and bases were secure. It became a fatal weakness when those conditions disappeared. At Henderson Field, the concept of proper parts ceased to exist by late September. The men started treating the growing pile of wrecked aircraft as a parts depot. A Wildcat destroyed on the ground by Japanese shelling might have an intact engine that could be transplanted into another airframe. A plane shot down offshore and recovered by Higgins' boat might yield instruments, wiring, hydraulic lines. Even aircraft damaged beyond any hope of flight were valuable. A single crashed fighter represented hundreds of salvageable components. The work happened in conditions that defied description. Tropical heat turned metal too hot to touch with bare hands. Afternoon rains flooded the work areas and turned every tool into a mud-caked weight. Mosquitoes carrying malaria swarmed in clouds. Dysentery was universal. Men worked with fevers, with infected wounds, with exhaustion so profound they would fall asleep standing up with wrenches still in their hands. Japanese bombs fell during the day. Japanese warships shelled the field at night. There was no safe time, no moment of genuine rest. Yet the aircraft kept flying. The daily status reports told a story that Japanese intelligence officers found increasingly difficult to explain. American planes they had confirmed destroyed were appearing in combat again. Aircraft they had counted as permanently disabled were intercepting raids. The numbers refused to make sense. By early October, Japanese planners were revising their estimates upward, assuming hidden reinforcements or underestimating initial deployments. The possibility that the Americans were literally rebuilding aircraft from wreckage did not fit within their operational understanding of how modern warfare functioned. The American command structure, to its credit, recognized what was happening and protected it. Officers who might have demanded adherence to regulations instead looked the other way. Inspection standards that would have grounded 3/4 of the aircraft were quietly ignored. The understanding was implicit and universal. The book of rules was written for peacetime, for rear areas, for conditions that no longer existed. Henderson Field operated under a single rule now. If it flies and fights, it's good enough. Everything else was theory, and theory had no survival value in the mud and chaos of Guadalcanal. The mechanics had become the most essential personnel in the entire campaign, though none of them wore pilot wings or fired shots in anger. They were winning the air war on the ground, one impossible repair at a time, and the Japanese had no idea it was even happening. The mechanics themselves came from everywhere and nowhere. Staff Sergeant James Sweat had operated a small engine repair shop in Sacramento before the war. His specialty had been making elderly farm equipment run for one more season because Depression-era farmers couldn't afford replacements. He approached aircraft engines the same way he had approached a 1920s thresher held together with baling wire and prayer. The question was never whether the repair was proper, the question was whether it would function for the next mission. Sweat developed a reputation for listening to engines. Pilots would taxi in and he would cock his head, hearing irregularities in the rhythm that instruments couldn't detect. He could diagnose a failing cylinder by sound alone, identify a fouled spark plug by the smell of the exhaust. This was not engineering. This was something older, a mechanical intuition built from years of working with machinery that refused to quit because the men depending on it couldn't afford for it to quit. Corporal Thomas Mann had worked on the Chevrolet assembly line in Detroit before enlisting. His gift was speed. He could disassemble and reassemble components faster than men who had been doing it longer. On an assembly line, speed was efficiency. At Henderson Field, speed was survival. Mann organized his work crews using production line logic. Each man had a specific task. No wasted motion, no waiting for the previous step to finish. He would have 3 engines in simultaneous states of disassembly, moving from one to another in rotation, keeping his hands constantly working. Other mechanics thought it looked like chaos. Mann knew it was choreography. He could swap an engine in 4 hours when the manual said it required 8. He did it by treating aircraft like products on a line and refusing to acknowledge that combat damage was supposed to slow the process down. Private First Class Eddie Bauer had grown up in rural Montana where the nearest mechanic was 40 miles of bad road away. Things broke on the ranch and you fixed them yourself or you went without. He had rebuilt truck engines using parts ordered from catalogs, often discovering the parts were wrong and making them fit anyway. Bauer's specialty became fabrication. When no replacement part existed, he made one. He carved new engine mounts from aluminum salvaged from crashed Japanese aircraft. He hand-formed exhaust manifolds by heating metal over fire and hammering it into shape on makeshift anvils. He cut threads into raw stock using dies he improvised from damaged bolts. Other mechanics would declare a component impossible to replace. Bauer would nod, disappear for 6 hours, and return with something that functioned. It rarely looked like the original, it always worked. The technical challenges they faced would have been impossible under normal circumstances. An aircraft engine is not a forgiving machine. Tolerances are tight. Balance is critical. A piston installed incorrectly can destroy an engine in seconds. An improperly torqued cylinder head can fail catastrophically at altitude. These men were performing precision engineering in mud with improvised tools under threat of imminent death. They had no way to dynamically balance crankshafts. They had no way to X-ray cylinder walls for hairline cracks. They had no way to pressure test fuel systems or verify magneto timing with oscilloscopes. They used their eyes, their hands, and their judgment. The process of rebuilding an engine started with assessment. The damaged engine was pulled and laid out on makeshift benches constructed from ammunition crates. Each component was inspected visually. Cracked parts were set aside. Salvageable parts were cleaned. The goal was to create one functional engine from the remains of 2 or 3 destroyed ones. Cylinders from different engines were mixed and matched. Pistons were swapped. Connecting rods were reused until they showed fatigue, then replaced with rods from other engines. The resulting Frankenstein assembly bore serial numbers from 6 different power plants. It violated every principle of engine management and maintenance tracking. It also flew. Cylinder heads presented particular problems. Battle damage often cracked the aluminum castings around the valve seats. Proper repair required factory equipment and skilled welders. Henderson Field had neither. The mechanics developed a technique using acetylene torches scavenged from construction equipment and welding rods that were technically incompatible with aircraft-grade aluminum. They preheated the entire cylinder head to reduce thermal stress, welded the crack, then slowly cooled. Let it buried in sand. The success rate was perhaps 60%. 40% of the time, the weld failed during testing and they started over. But 60% of otherwise destroyed engines returning to service was 60% more aircraft in the air. The Japanese expected those aircraft to be gone. The mechanics refused to let them be gone. From the Japanese perspective, the situation made no tactical sense. Commander Tadashi Nakajima, an intelligence officer with the 11th Air Fleet, kept meticulous records of American aircraft losses based on pilot reports and reconnaissance photographs. His logs showed clear patterns. The Americans had landed approximately 40 fighters on Guadalcanal by early September. Japanese attacks had destroyed or damaged at least 30 of those aircraft by late September. Reinforcements were arriving, but slowly and in small numbers. The mathematics predicted American air strength should be declining to unsustainable levels. Instead, the number of aircraft rising to meet each raid seemed to hold steady or even increase. Nakajima wrote in his diary that either American reinforcements were far larger than intelligence indicated or something fundamentally wrong existed in the data. He never considered the third option, that the Americans were refusing to accept his mathematics. The Japanese military culture, for all its emphasis on fighting spirit and offensive aggression, maintained rigid adherence to technical standards and procedural correctness. A Japanese aircraft declared damaged beyond field repair was written off and replaced through proper supply channels. Japanese mechanics were skilled and dedicated, but they operated within doctrinal boundaries. Improvisation was not encouraged. Deviation from technical specifications was viewed as introducing unacceptable risk. This approach had served Japan well during the early conquests when supply lines were short and bases were secure. At Guadalcanal, where those conditions no longer applied, it became a strategic vulnerability the Japanese High Command never recognized. The innovation happening at Henderson Field went beyond simple mechanical repair. It represented a fundamental philosophical difference in how Americans approached problems. The men working in the mud had been raised in a culture that celebrated the tinkerer, the inventor, the person who made do with what was available. American folklore was filled with stories of barn-built airplanes and garage-invented machines. The Depression had taught an entire generation to repair rather than replace, to improvise rather than wait. These were not abstract values. They were survival skills now being applied to industrial warfare. One innovation that emerged from pure desperation was the practice of partial engine runs. Proper engine testing required running the engine at full power for extended periods to verify performance. Henderson Field rarely had that luxury. The mechanics developed the ability to test an engine through a 2-minute ground run, listening to subtle variations in sound, watching for smoke or vibration, feeling through the airframe for irregular harmonics. Experienced mechanics could identify problems in seconds. It should have required hours of diagnostic testing. They were compressing the engineering process through intuition and accumulated experience. It was not scientific. It was also remarkably effective. The leadership at Henderson Field deserves recognition for creating an environment where this kind of innovation could flourish. Lieutenant Colonel Harold Bauer, the commanding officer of VMF 212, had been a Naval Academy graduate who understood both military protocol and practical necessity. He made a deliberate decision to shield his mechanics from higher headquarters interference. When visiting staff officers questioned non-standard repairs or unauthorized modifications, Bauer would politely inform them that his mechanics were operating under combat conditions, and he would take full responsibility for any deviations from standard procedure. He never once grounded an aircraft because it failed to meet peacetime technical standards. His pilots trusted the machines because Bauer trusted the men who built them. This trust extended into the cockpit. Pilots knew they were flying aircraft assembled from parts that had no business being in the same engine. They knew their planes had been hit, crashed, burned, and resurrected. They flew them anyway because the alternative was not flying at all. Lieutenant Colonel Joe Foss, who would become one of America's leading aces, later said he never once questioned whether his aircraft would perform. The mechanics had earned absolute faith. If they said the plane was ready, it was ready. This bond between pilot and mechanic became one of the intangible advantages that never appeared in Japanese intelligence estimates. The scale of the improvisation expanded as the campaign continued. By mid-October, mechanics were not just rebuilding engines but modifying them. They increased boost pressure on some engines to generate more power, accepting reduced engine life in exchange for better combat performance. They removed weight by stripping non-essential equipment. They fabricated custom parts that improved reliability under Guadalcanal's brutal conditions. Some of these modifications were later adopted officially by the Navy after engineers stateside examined them and realized the field mechanics had independently solved problems that had stumped design teams. The men covered in mud and oil had become inadvertent innovators, advancing the state of aviation maintenance simply by refusing to accept that broken meant finished. October 13th arrived with intelligence that promised disaster. Coast watchers up the slot had radioed warnings of a major Japanese air raid forming at Rabaul. At least 24 bombers with fighter escort would arrive at Henderson Field sometime after dawn. The goal was obvious: destroy American air power on the ground before the next phase of Japanese offensive operations. Tokyo had committed to retaking Guadalcanal. Control of the air was the prerequisite. Everything depended on the next 12 hours. At 2100 hours on the 12th, the situation was grim. 4 Wildcats were fully operational. 2 more were marginal, flyable, but with mechanical issues that would ground them under any other circumstance. 3 others sat in the revetments with damage that ranged from serious to catastrophic. One had taken a 20mm cannon shell through the engine cowling that had cracked the crankcase and shattered 2 cylinders. Another had made a wheels-up landing after losing oil pressure, bending the propeller and damaging the engine mounts. The third had been strafed on the ground 2 days earlier, riddled with machine gun fire that had punctured fuel lines, destroyed the instrument panel, and perforated the oil cooler. Major Joe Renner, the operations officer, looked at the status board and did mathematics that didn't work. 6 aircraft against 24 raiders meant the Japanese would get through. Bombers would crater the runway. Parked aircraft would be destroyed. The entire defensive position would collapse not through being overrun, but through being unable to contest the air. He walked to the maintenance area where Sergeant Gaylor was already elbow-deep in the engine of the crashed Wildcat. "How many can you give me by dawn?" Gaylor didn't look up from the crankcase he was inspecting. "How many do you need?" "All of them." "Then all of them." It was not bravado. It was a contract. The mechanics had 6 hours to perform miracles, and they had been performing miracles every night for 2 months. This night would simply require a larger miracle. Word spread through the maintenance crews instantly. Every available man converged on the 3 damaged aircraft. The division of labor was instinctive. The most experienced mechanics took the engine work. Younger men handled everything else. Runners moved between aircraft carrying parts, tools, anything needed. A human supply chain emerged from chaos. The Wildcat with the cracked crankcase was the worst case. The entire engine needed replacement. Gaylor's team had exactly 1 spare engine, pulled 3 days earlier from a plane that had nosed over during landing. That engine was partially disassembled for inspection and hadn't been cleared for use. It didn't matter. They would install it, run it, and pray it held together. 4 men lifted the replacement engine using a tripod hoist made from bamboo and cargo straps. The precision required to mate an engine to an airframe normally took hours of careful alignment. They did it in 40 minutes, using flashlights and hand signals and muscle memory. The wheels-up Wildcat had a bent propeller and damaged mounts, but the engine itself was potentially sound. Corporal Mann's crew attacked the propeller. In theory, propellers damaged by impact were to be returned to depot for inspection and rebalancing. In practice, they had no depot and no replacement propellers. Mann used a sledgehammer and a tree stump as an anvil. He heated the bent blades with a blowtorch and hammered them back into approximate alignment. It was barbaric. It was also the only option. The propeller would be out of balance. It would vibrate. It might fail catastrophically at high RPM. But it would turn, and a plane with a rough propeller was better than a plane with no propeller. The strafed Wildcat presented different problems. The engine might be intact, but the auxiliary systems were destroyed. Private Bauer took charge of the fuel system repair. Every line needed replacement. He had no proper aircraft fuel lines. He used rubber hoses scavenged from a destroyed truck, cutting and fitting them to approximate the routing of the original lines. The connections leaked. He sealed them with friction tape and hope. The oil cooler was beyond repair, shot through with holes. He removed it entirely and fabricated a bypass using copper tubing hammered flat and bent into shape. The engine would run hot without a cooler. It would run hot for 1 mission, maybe 2. That was enough. Midnight came and went. The work continued under lights that made everyone a target if Japanese bombers appeared. They didn't. The Tokyo Express had sailed earlier, delivering the shelling that was supposed to soften Henderson Field before the morning raid. The battleship bombardment had been terrifying but relatively ineffective. Most shells had fallen in the jungle or cratered empty sections of runway. The aircraft had survived. Now they just needed to fly. At 0200 hours, Gaylor's team finished bolting the replacement engine into the first Wildcat. Fuel lines connected, control cables rigged. instruments wired. It looked complete, but completion meant nothing until the engine fired. Gaylor primed the cylinders, set the mixture, and hit the starter. The propeller turned, the engine coughed, turned again, coughed again, then caught with a roar that sent flames shooting from the exhaust stacks. The entire aircraft shook. The engine was running rough, missing on at least one cylinder, but it was running. Gaylor let it warm for 2 minutes, then shut it down. One aircraft recovered. At 0330, Mann's crew finished their work on the second Wildcat. The hammered propeller was installed. The engine mounts had been reinforced with plates cut from a wrecked Japanese truck. It looked like something assembled by a madman. Mann climbed into the cockpit himself and started the engine. The vibration was immediate and severe. The entire aircraft shuddered like it was tearing itself apart. Mann ran it up to half throttle. The vibration increased but didn't worsen. He held it there for 30 seconds, listening, feeling, making a judgment call that would either save or kill the pilot who flew this machine. He throttled back and shut down. It would fly. The pilot would have to deal with the vibration. 2 aircraft recovered. Bauer's fuel system repair was finished by 0415. The engine started normally, ran smooth for 60 seconds, then began losing power as the jury-rigged fuel lines started leaking under pressure. Bauer shut it down, tightened every connection, wrapped everything in additional layers of tape, and restarted. The leak slowed but didn't stop. Fuel was dripping onto the hot engine, a fire hazard that violated every safety protocol. Bauer made the call. It would fly until the fuel lines failed completely. How long that might be was unknowable. 3 aircraft recovered. Dawn was 40 minutes away. Ground crews were arming the 7 flyable Wildcats with 50 caliber ammunition and fueling them from hand-pumped drums. The pilots were already in their cockpits, engines warming. They had been briefed on the status of their aircraft. The 3 resurrected fighters were marked with red paint on the cowling so pilots would know they were flying something marginal. No one refused to fly them. At 0520 hours, the Coast Watcher Network reported the Japanese formation had launched from Rabaul. Estimated time to Henderson Field was 35 minutes. Renner gave the order, all aircraft scramble. The 7 Wildcats began rolling toward the runway. The 3 rebuilt aircraft were deliberately positioned last in the takeoff sequence. If one failed on takeoff, it wouldn't block the runway for the others. The first 4 aircraft got airborne without incident. The 5th, one of the marginal planes, showed rough running but climbed away successfully. The 6th accelerated down the coral strip, bouncing over the uneven surface, then lifted into the morning air, trailing a thin stream of oil smoke. The 7th, Bauer's fuel system repair, began its takeoff roll. The engine was running but losing power. The Wildcat used every foot of runway before staggering into the air barely above stall speed. It stayed airborne, clawing for altitude, the pilot nursing the throttle to keep the failing fuel system feeding the engine. At 10,000 feet, the 7 Wildcats formed up and turned north. Below them, Henderson Field looked like a graveyard of aviation. Wrecked aircraft lined the field. Shell craters pocked the runway. It looked like a base that had been defeated. From altitude, you couldn't see the mechanics collapsing into exhausted sleep in the mud. You couldn't see the tools still scattered around the work areas. You couldn't see the miracle that had just occurred. At 0602 hours, the Japanese formation appeared as dots on the horizon. 27 Betty bombers in tight formation, with 18 Zero escorts weaving above them. The Japanese pilots saw the 7 American fighters rising to meet them and felt the first tremor of confusion. Intelligence had said American fighter strength was nearly depleted. These 7 aircraft should not exist. Where had they come from? Had reinforcements arrived during the night? The Japanese formation leader didn't break formation. Orders were orders. The target was Henderson Field. They continued south. The American fighters hit them head-on. 7 against 45 were impossible odds, but the mathematics of air combat don't scale linearly. 7 determined fighters attacking a bomber formation create chaos out of proportion to their numbers. The Wildcats dove through the zero screen, ignored the escorts, and went directly for the bombers. Guns hammered, bombers staggered. The tight Japanese formation began to loosen as pilots took evasive action. Bauer's Wildcat, the one with the failing fuel system, got in one high-side pass before the engine quit entirely. Fuel starvation. The jury-rigged lines had finally failed. The pilot, Lieutenant James Sweat, didn't try to restart. He put the fighter into a glide, aiming for the coastline. He made it to the water and ditched successfully a quarter-mile offshore. He would be rescued 2 hours later by a Higgins boat. His aircraft sank in 30 seconds. It had flown for exactly 7 minutes of combat before the improvised fuel system gave up. Those 7 minutes had been enough. Mann's vibrating Wildcat stayed in the fight longer. The pilot reported feeling like he was riding a jackhammer, but the guns worked and the engine kept producing power. He shot down one Betty, damaged another, then felt the propeller vibration suddenly intensify. Something in the hub assembly was failing. He broke off and headed for Henderson Field, landing with the propeller shaking so violently that pieces of the spinner flew off on touchdown. The aircraft was grounded permanently after that flight. It had given one mission. One mission had been all it needed to give. The rebuilt aircraft with the replacement engine fought for 12 minutes before being shot down by a Zero. The pilot bailed out over friendly territory and walked back to Henderson Field that afternoon. The engine that Gaylor had installed in darkness, that had never been properly tested, had performed flawlessly until Japanese bullets, not mechanical failure, ended its service. The Japanese raid was broken up short of the target. Only 8 bombers made it to Henderson Field, dropping their loads from high altitude with poor accuracy. Minimal damage resulted. 4 Japanese bombers were shot down. 3 more were damaged and crashed attempting to return to Rabaul. The Japanese lost 11 aircraft. The Americans lost 2 fighters. Both pilots recovered. By the cold accounting of aerial combat, it was a clear American victory. But the real victory was invisible to the Japanese pilots who survived to file their reports. The Japanese intelligence officers received the pilot debriefs with mounting confusion. 7 American fighters had intercepted the raid. 7. The operational estimates had predicted perhaps 4 or 5 aircraft available to the Americans that morning. The discrepancy was small but significant. Where had the additional aircraft come from? No convoys had been detected overnight. No transport flights had been observed. The Americans appeared to be generating fighter strength from nothing. Commander Nakajima updated his logs with increasing frustration. The pattern had been consistent for weeks. Japanese attacks destroyed American aircraft with regularity. The wrecks were visible on reconnaissance photographs confirming the kills. Yet American fighter strength never declined to the levels mathematics predicted. He wrote detailed reports arguing that American reinforcement rates must be higher than currently estimated. His superiors agreed and revised their intelligence assessments. The possibility that the Americans were resurrecting destroyed aircraft did not enter the analysis because such a thing was not possible according to Japanese understanding of modern military aviation. At Henderson Field, the mechanics were already back at work. 2 aircraft had been lost. 2 aircraft needed to be replaced. The wrecks from the morning's combat were towed back to the field by late afternoon. Both were damaged but salvageable for parts. The pilot who had ditched offshore reported his engine had failed due to fuel system problems. Bauer took responsibility and immediately began designing a more robust field repair technique for fuel lines. The aircraft with the destroyed propeller hub was stripped for parts within hours of landing. The engine, still intact, would be installed in another airframe within 2 days. The victory was recognized at the command level. Major Rennie sent a commendation report to division headquarters specifically naming the mechanics who had worked through the night. Several would receive Bronze Stars for their actions, though the citations would be vague about the specific technical violations involved. The official paperwork described extraordinary initiative and dedication to duty under combat conditions. It did not mention crankcase welds or hammered propellers or fuel lines made from truck parts. The morale impact rippled through the entire Henderson Field garrison. The Marines holding the defensive perimeter heard that the morning raid had been defeated. They didn't know the details. They didn't need to know. The fact that American fighters were still flying, still fighting, still winning meant they were not abandoned. It meant the Air Force, tiny and battered as it was, would still be overhead when the next Japanese ground assault came. That knowledge was worth more than reinforcements. The psychological effect on the Japanese was harder to measure but no less real. Pilots returning to Rabaul reported that American air defenses remained strong despite weeks of attrition. This contradicted the strategic narrative that Japanese commanders had been building. The narrative said American strength was declining. The narrative said Guadalcanal was on the verge of collapse. The narrative said one more major push would break the defenders, but if American air strength was not declining, then the narrative was wrong. And if the narrative was wrong, then the entire operational plan for retaking Guadalcanal needed reconsideration. Through October and November, the pattern continued. Japanese raids arrived. American fighters, sometimes only 4 or 5, rose to meet them. Damaged aircraft that should have been written off reappeared in combat days later. The Japanese kill claims mounted into the hundreds, yet the Americans kept flying. The mathematical impossibility of the situation began to affect Japanese planning. If attrition was not working, then what would work? The answer increasingly seemed to be nothing short of overwhelming force. The broader strategic picture was shifting in ways neither side fully understood in the moment. The grinding air battles over Guadalcanal were bleeding Japanese pilot strength at an unsustainable rate. Veteran aviators, the men who had attacked Pearl Harbor and conquered Southeast Asia, were being killed or worn down by exhaustion and tropical disease. The replacements arriving were less experienced, less capable. Meanwhile, American pilot quality was improving. The survivors were becoming veterans. The tactics were being refined. The aircraft, cobbled together though they were being flown by men who knew how to use them. The mechanics at Henderson Field received official recognition when Navy engineers finally visited in late November to assess field conditions. The engineers arrived expecting to find a deteriorating maintenance situation requiring immediate intervention. Instead, they found organized chaos that was somehow maintaining aircraft availability rates better than some rear area depots. The engineers interviewed mechanics, examined the improvised repairs, and documented innovations that violated every standard procedure. Their report concluded that while the techniques used were highly irregular, the results were undeniable. Several recommendations were made to formalize some of the field modifications for broader adoption. Staff surge. Ant Galler's crankcase welding technique was studied and refined by Navy metallurgists. With proper welding rods and improved preheating procedures, it became an authorized field repair for specific types of damage. Corporal Mann's engine swap procedures were analyzed for time efficiency. Elements of his approach were incorporated into revised technical manuals for expeditionary maintenance. Private Bauer's various fabrication techniques were documented as examples of acceptable field expedient repairs when proper parts were unavailable. The men who had invented these techniques out of desperation became inadvertent contributors to military maintenance doctrine. The human cost was significant but largely invisible. The mechanics worked themselves to physical breakdown. Malaria hospitalized a third of the maintenance personnel at various points. Exhaustion-related accidents injured others. 2 mechanics were killed when a Japanese night raid caught them working on exposed aircraft. The work was never safe and never stopped. When mechanics were too sick to stand, they sat on ammunition crates and continued working. When their hands shook from fever, they tied tools to their wrists so they wouldn't drop them. The dedication bordered on obsessive because the alternative was unthinkable. By December, American control of Guadalcanal was secure. Henderson Field expanded from a single coral strip to a full airbase complex with multiple runways, proper revetments, and eventually real maintenance facilities. Supply lines stabilized. Replacement parts began arriving with regularity. The desperate days of improvisation began to fade into memory. The mechanics who had kept the Cactus Air Force flying were rotated home, replaced by fresh personnel who would never fully understand what their predecessors had accomplished. The Japanese never solved the puzzle of Henderson Field. Post-war analysis of Japanese intelligence documents shows they consistently overestimated American aircraft numbers on Guadalcanal throughout the campaign. They never understood that the Americans were not receiving massive reinforcements. They never grasped that the same aircraft were being killed, resurrected, and killed again. The concept was too far outside Japanese operational doctrine to be seriously considered. This intelligence failure contributed to faulty strategic planning that committed resources to a battle that was already lost. The final accounting showed that Henderson Field mechanics maintained an average aircraft availability rate of approximately 50% throughout the critical period from August to December 1942. In peacetime, such a rate would have been considered a catastrophic failure. In combat, with no supply chain and constant battle damage, it represented a triumph of human ingenuity over impossible circumstances. The Japanese, operating from established bases with intact supply lines, maintained availability rates of approximately 65%. The 15-point difference should have been decisive. It wasn't, because the Japanese calculations never accounted for the American ability to resurrect the dead. Decades later, military historians studying the Guadalcanal campaign would identify Henderson Field mechanics as an unrecognized critical factor in the American victory. The air battles get remembered. The pilots become legends. The ground combat is documented in painful detail. But the men covered in oil and mud, working through the night to make broken things fly, remain largely forgotten outside specialist military histories. This is unfortunate because their contribution represented something fundamentally important about how America fought the Second World War. The mechanics embodied a cultural approach to problem solving that was distinctly American. They came from a society that celebrated the practical inventor, the garage tinkerer, the person who made do with available resources. The Depression had reinforced these values across an entire generation. When the war demanded impossible solutions, these men provided them not because they were ordered to, but because they had spent their lives learning how. They saw a broken aircraft not as a write-off, but as a challenge. They saw a lack of parts not as an insurmountable obstacle, but as an invitation to improvise. The Japanese approach was not inferior, merely different. Japanese engineering and manufacturing were world-class. Japanese pilots were superbly trained. But the Japanese system assumed logistical stability and procedural adherence. When those assumptions broke down, the system struggled to adapt. The Americans, by contrast, had built flexibility into their cultural DNA. The mechanic who had kept a Depression-era tractor running with baling wire saw no fundamental difference between that and keeping a Wildcat flying with parts from 3 different engines. Both were problems that required solutions. Both could be solved if you were willing to ignore the people telling you it couldn't be done. This philosophical difference extended far beyond one airfield on one island. Throughout the Pacific War, American forces demonstrated remarkable ability to adapt, improvise, and overcome logistical challenges through innovation rather than procedure. The Japanese, despite their technological sophistication and warrior dedication, struggled to match this flexibility. The Guadalcanal mechanics were an early and dramatic example of a pattern that would repeat across the entire theater of war. The lesson transcends the specific historical moment. Modern military logistics still grapple with the balance between procedural control and field initiative. Today's aircraft are exponentially more complex than World War II fighters. The possibility of improvised repairs seems remote in an era of computer-controlled systems and micro-tolerances. Yet the fundamental challenge remains unchanged. How do you maintain capability when the perfect solution is unavailable? The answer developed at Henderson Field still resonates. You trust the people closest to the problem. You protect their ability to innovate. You judge results rather than procedures. And you recognize that sometimes the most important victories happen not in the air, but in the mud, where broken things become whole again through human will and mechanical skill. The mechanics at Henderson Field never imagined they were making history. They were simply doing the job in front of them, making the next aircraft ready for the next mission. That their work confused Japanese intelligence and contributed to strategic victory was almost incidental. They were not fighting a grand campaign. They were keeping promises to pilots who depended on them, meeting the challenge placed before them by circumstances they didn't control. In doing so, they became part of something larger than themselves, a collective effort that turned the tide of a war, one repaired engine at a time. The wrench turned, the metal held, the aircraft flew, and the impossible became routine, until routine became victory.